Here are 5 reasons to start podcasting. First, talk about things that you're passionate about, and you have a lot of information, and also get other people to talk about their companies, the products that they work on, and things that they enjoy doing. Two, establish yourself as an expert. Three, help establish a network of people who are interested in the same subject material that you are talking about. Four, facilitate cross pollination of ideas. So, as more people get on the network and more innovative ideas are shared, there will be more cross pollination of ideas. And five, earn money before the market gets saturated. So there's an urgency for you to get out and start blogging.
Uh, Definitely. So when I was starting out, right, I actually was looking for the very popular use cases like autonomous driving as well as gesture recognition. But there's this particular video that I found. It was about a lady named Tanya, and she actually had a lot of problems, as in she was unable to speak and move, and she helped Google to develop a machine learning software which could use which people with disabilities could use to generate sign language as well as the Morse code. So because of her story, we have I mean the Google integrated that Morse code generator machine using machine learning into their mobile phones. So I think that is something that I'm really looking forward to. That is to help people into developing something of their own and helping the community eventually. So yeah, so the work that I'm doing currently, gesture recognition, is mostly for developing a model for Indian Sign Language, which I want to open source so that other people can maybe draw some inspiration and do something which is which I mean which could be used to help people with disabilities.
That's really great. There's so many applications to the gesture recognition because we communicate with natural language, but we also communicate with body language. Our When you're talking to someone, if they are not paying attention, you get the idea that they're not interested. If they are communicating and their pupils are dilating and they're looking at you really intense, either they're very interested or they're angry, or there's a lot of body language communication that's going on. How did your how did it work for her? I'm interested to find out. Can you kind of walk us through a day using the software? What kind of things was she able to do with it?
Okay, so currently, um, I mean, one point that you mentioned that I really liked is that attention, looking at the looking at the body language. I think that's very good. That's very cool. Because similar thing is happening in China right now. I think in classrooms they have installed these cameras, which can monitor all the students, and they can tell what's the attention span of each student based on their body language as well as their eye movement, where exactly they are looking. So I think it has a lot of cases. And now coming back to your question about how the day is like basically. So of course, I mean before machine learning and AI, things were pretty difficult for people with who are specially abled. But with the advent of these technologies, I think people are getting. I mean, people like Tanya now have some sort of help in which they can use Morse code as well as sign language to communicate. So for when I was starting out, when learning about sign language, I first had to study for about 2 or 3 months about Indian Sign Language. Okay, and then once I have had some idea, I was able to develop some prototype So basically, what this prototype does is that, based on uh, the sign that the person is communicating, I can record that, and via webcam, I can directly get those images of the person signing, and then I can convert that into a sentence or a word or a gesture. And then let's say, even if I don't know sign, if a person does not know sign, he will be able to understand what exactly the person is trying to convey. And the problem with Indian Sign Language is that we have different sign languages for different regions. So within, let's say, in India, there are, let's say, 20 to 25 different sign languages for different regions. And in America, in the US, we have only one American Sign Language system. So I think that is pretty, a very universal in American Sign Language. So what I'm looking for is to maybe have a proposal in which I would encourage every school for sign language in India to follow a specific pattern, so that all the signs within India could be universal. So that is something that I'm looking forward to.
You mentioned that you also did autonomous cars, and I see the correlation here between the sign language, because when a car is driving, it's having a conversation. It's looking at an object, and it's to the right. It's saying, "Okay, I'm coming to an intersection. I see the intersection light, and it's red. Red means to stop. Oh, I see a pedestrian to the left. The pedestrian's walking from left to right. Uh, do not proceed until the pedestrians across the intersection. Oh, I see a bicyclist to my right. Um, it's not obeying the rules. It's going to swerve in front of me. I need to slow down." So I could see some universal um, applications here where you're creating conversations, because you definitely want to have a conversation with an autonomous driving car that is creating a script, so that if there were an accident, or if it did made an improper decision, you could review the script. How did Tanya do when she started using your software? Did she find it um, fast enough? Was she doing the sign languages and it was getting the signs right 90% of the time, or was she saying things that didn't make sense, and then um, you had to build software to kind of like grammarly parse it and try to figure out the
Yeah.
proper word?
So basically, I mean, the story about Tanya, right? She actually is kind of an inspiration. I did not get to work with her, but I would share the link with you. She actually worked with Google into coming up with a software for Morse code. I am currently working on sign language, which is still in kind of development phase, what I'll say. So the first phase is complete, which means that in that phase I have looked at only static images, right? So I'm able to convert and translate static images to get the results. But the next phase for my sign language would be to have a sequential model, as in based on the context. Let's say, if I have to say a sentence, right, a sentence will become comprised of number of words, and each word will have a different gesture, right? So based on the context, I want to develop a model which I am currently working on. That is basically, it will take each gesture, um, and then it will translate the entire all the gestures, and form a sentence out of it. So that is a bit complicated, as in you have to parse the context from the first word to the last word in the sign language. But yeah, I think that is kind of interesting, because that is going to help me reach out to a lot of a variety of signs. So currently it's only about static images. I'm looking at one image, I'm trying to map it to a specific gesture. But going forward, I'm definitely looking to go ahead and map the entire sentence, or maybe even paragraph, to a specific gesture, so that it helps people to convey the whole context and not just one specific gesture.
Yeah, that's what I would say with communication, that's important, because when you look at it as a sentence, and when we're talking, we're conveying complete
Yeah.
ideas, and so it's difficult just with one gesture to complete an idea.
Yeah, definitely. Yeah.
Can you talk about your autonomous driving? I'm really interested. Before we go to that, what type of classifier do you use? Are you using machine learning, um, uh, what type of image recognition software, or yeah, maybe talk about the software. Did you write your own software?
Yes.
Um,
Definitely, I think that's a
how
very
did you do
good
it?
question. Yeah. So when we talk about autonomous driving, right, it comprises of different parts. So one part is detecting the pedestrians on the street. One part can be detecting the let's say different objects on the street. One part could be detecting the traffic signal on the street, right? So these are different modules within autonomous driving which should work together in harmony to make a fully functional autonomous driving. So what the model that I created was, it's called as behavioral cloning, which means that given a image of the road, I should be able to predict the angle at which my steering wheel should be at. Okay, so that's the first thing. So there's a very good research paper by Nvidia where they gave us the data which was images, and per image they actually mentioned the steering angle that should be. So let's say if there's an image of a road where there's a left turn, then the angle would be somewhere tending towards the left side of the screen, which means that I have to take a left turn. So for this model, I used a very simple a neural network, which was basically a deep CNN network. CNNs are used because it's actually very helpful when it comes to images, and I wanted to. So basically, the main goal was to get the steering angle based on the road. So I just wanted to separate out the road from the entire image, because the entire image was pretty huge, and it was difficult for somebody to calculate, and it will take more time to calculate on the entire image. So what I did was, I first of all scaled the image and only took out the road section of that image, and for that I applied several filters using computer vision. And then when I out only the roads, like the roads and some of the other stuff, then I was able to feed that into a CNN network, and based on the different networks, and it was a very simple network. I had, I think, two CNN networks, and then at the end I was predicting the steering angle, and then I was using a mean squared error function to make sure that the angle which the model predicts and the actual angle are somehow similar. And then based on that I was making predictions on the runtime. And if you look at the video, what happens is, based on the road, my steering wheel is tilting at a certain angle. So that was pretty much it. The idea behind the model was to make sure that I use as less resource as possible, and to build a better model. So if you look at the Nvidia paper, they were actually using 103,000 trainable parameters, but because I was separating out only the roads, I could train the same model with similar accuracy with only 70,000 trainable parameters, which is a considerable upgrade. And people which don't have access to GPUs can also train it in less time. So I think that's a good thing.
Yeah. So when you were talking about the algorithm that detects the road, and then if you're making a left turn, it leans to the or turns to the left. Um, did it was it? You said it was calculating using a mean square algorithm, so you were doing some sort of curve fitting to the road. So it was looking at points out into the future, and it was or along the line or the spline, and then it was calculating what it thinks would be the new position, and then it calculates that angle to that position using the CNN neural nets. How how do you how did you keep from it running off the road? For example, what if it saw an area that was dipping down lower? How did you keep from running off the road?
Yeah, I think that's a very good problem, because I faced similar issue. So basically what happened was, I was training too much on the training data, and therefore when I was running it on a new video of a road or of a car ride, my predictions were all over the place. So even for the left turn, I was taking a right turn. So that was a bit concerning for me, because even though I had made a good model and I did a lot of data cleansing, but still the model was not performing well. So in that case, what I would recommend is probably go back to the drawing board, start maybe do something with the network architecture, because most of the time the network architecture is the backbone of your model. So for that, I so clearly after a couple of iterations, I was clear that I was overfitting the training data, which means that I had trained my model too much on the training data, and whenever the model
Wow.
was seeing a new image, he was unable to predict it, because I have trained my model too much. So for that, this is a typical problem of overfitting. So for that, if you want to solve that, you have to there are a couple of things that you could do. I went for a dropout method. So in the dropout method, what happens is you are supposed to block a certain network, a certain nodes in the network, so that the model learns from all the nodes. So I'll give you a very easy example. So let's say if there are two features which are unrelated. Let's say for instance, the average age for entering a beauty pageant has decreased over 10 years, right? So let's say in 1990s it was 24, then over the period of time it decreased to, let's say, 20. And then the average crime rate also decreased in let's say in India, from about 20% it decreased to 15%. And let's say if these two, by common sense you can see that these two features are completely different. But let's say if you feed this to a model, maybe the model will have a correlation that the fall in the crime rate is directly proportional to the fall in the age for entering a beauty pageant.
Okay.
So for that, you have to make sure that the model learns from different nodes within the network and not just from a specific nodes. So the dropout, what it does is that it blocks certain nodes from learning for some period of time, so that other nodes can also learn. So this actually helps into when you are overfitting. It helps to make sure that all the nodes get equal amount of attention from the network, and all of them are trained properly. So this is one thing that I use, and it's very effective in networks, yeah, in neural networks. And yeah, and then after that, the problem was solved after, I think, I used a dropout and I blocked around 40% of the nodes at one iteration, and it was working fine after that.
That's great. So, also going back to the sign language, did you use TensorFlow? I mean, can you use TensorFlow in the driving to create kind of a natural language script of what's going on? So you're now following the road through using splines and angles and CNN networks, but you also have to recognize what's going on. You need to know the interactions of objects around you, because not everything is going to be static. There's a tree,
Yeah.
static. There's a rock, that's static. But then when you get to an intersection in India, it's going to be very difficult for you to navigate if you don't know what other cars are doing. And they have to, and it has to be, there's have to be some probability of what other cars are doing, because if someone honks their horn, that is an indicator um, and sound that it's safe for you to proceed. So you're going to accelerate. If someone is moving towards you in a dominant manner, like if their proximity, you're saying, oh, the person is approaching me at a rapid pace, you might want to yield because they're exerting their dominance in that driving pattern. So it has to know what the objects are around them. Can you speak to that a little bit on how you would handle those
Yeah,
situations?
definitely. I think that's a great point. So basically, as I mentioned, that for autonomous driving, you have to take care of a lot of things. So the particular point that you mentioned about the driveway or the path. So this actually comes under the path planning algorithm, in which the car has to predict a different number of paths that it might take. Because let's say if there are two cars and I am driving an autonomous car, and my path, the prediction of the path is, I'll swerve between those two cars. But what if the car on the right comes to the center, and then I'll have to, at runtime, make sure that I predict that the car on the right has moved to the left, and now I have to take a right turn again and then swerve from the right of the center car. So I think that's very interesting. One of the things that we could do is have different what can you say, different sensors on the car. So it's not just a camera in the front. There could be cameras on the side as well. There could be cameras on the top which could get a clear view of the road ahead. And one thing that I actually was working on is basically we can develop a model for detecting cars on the road. And let's say if, and I can also detect the car, and I can also detect the area of the car, let's say in terms of a rectangle, which would be ahead of me. And let's say if that person applies brake, right, so the car will come close to me, as in I'll move towards the car, therefore the area of the car will actually increase, because if the car is far, then the area if you look from the back, the area of the car will be small. If you move close to it, the area of the car will become big. So we can apply some sort of threshold value, and that if the area of the car which is ahead of you is greater than some threshold value, which means that I should also apply brakes, because probably the person who's driving the car ahead of me has also applied brake. And so yeah, we can have these sort of thresholds value, different sensors, to make sure that we have a good model running. And one other technique that I would probably recommend is to have everything on the edge. That is, the calculation should be done on the cloud, because it is quicker. You can have even if if your model takes a lot of time to predict, that doesn't matter. You can have more compute power on the cloud, so the car can only just send data and get the response as quickly as possible, because even a fraction of second matters in such situations. So that's one thing that I will probably say is the most important, is to have everything on the cloud, and the car should just communicate, and the training and the prediction should be done on the cloud itself and not in the car.
Well, we have sensors now that are getting lower costs, like the LIDAR
Yeah.
is becoming cheaper. Talk to me about how um, you think the machine would negotiate a car that's making a left-hand turn in front of you, where there is no traffic signal. You don't have a traffic light. It wants there's a you're moving on the busy roads of India, and it wants to turn left, so it's indicating it wants to go.
Yeah.
Would it slow down, or would it say, okay, I'm going to keep going forward? Um, there has to be a conversation between the objects.
Yeah.
In other words, it's detecting some objects, and there's some sort of language that's going on there. Can you talk on that?
Yeah, so let's say if a car ahead of me is going to take a left turn and I need to know about that. So as a human being, it's easy, right? You can just see and look at the car which is slowing down, and then also you can look at the indicator which will be blinking towards the left side. So yeah, so that's how humans will learn. And maybe what we could do is have a camera which can see the car ahead of you. And first of all, as I mentioned, that if it will slow down, right, it will come close to my car, and the area of the car will increase if I look at it. So yeah, so I'll probably have an understanding that it is slowing down. So I'll also decrease my pace similarly. And then I can also detect the if there are any indicators involved or not. So let's say if the indicator is of yellow color, I can have a detector of yellow color within the screen. And if I am able to see that the side of the car is blinking, which means that the car will probably take a left turn, and it is slowing down as well, which means that it's most probably will take a left turn. So in that way, the communication is happening between my car and the car in front. And I'll also slow down. If I have to take a left turn, I'll follow the car. Or if I have to take a right turn, I can just swerve towards the right and then go straight ahead. So yeah, I think that's a very important point, that all the machines should be communicating at all times, and because we have to pass information from one car to another. And I think these sensors, like the lidar sensor that you mentioned, I think all of them have enough data to help us take a informed decision.
And also it could, there's a conversation. So you said it would then detect the signal, but also it could be watching the driver's eyes or face. For example, if the person is really intense and they want to look, they're signaling with their facial gestures that they want to make a left-hand turn, you might yield to them. So your box that you were talking about in proximity, it's getting smaller as you're getting closer to that car.
Yeah.
But the other person signaling in their body language, just like with the sign language, that they want to do a left-hand turn, you might want to slow down if it passes a certain
Yeah,
threshold.
definitely. I think that's a good point, because let's say if they have to take a left turn, they'll keep looking towards the left of the screen, and that is an indication that maybe they have something which interests them on the left side. Maybe they want to take a left turn, or maybe they just want to stop. So yeah, that's an indication that that should be communicated to my car, and then yeah, and then based on the feedback, I can maybe slow down, take a right turn, and overtake them from the right. But yeah, I think it's important to have, because we have all these sensors which can help us make a more informed decision. So the more sensors that we have, as long as they don't become too heavy, because we need to make sure that all the predictions are done in near real time. So we cannot have, let's say, 100 different sensors, because collecting data from them and then sending them to prediction, making predictions, and then getting the results back can take a lot of time. So yeah, I think, but having these sensors is actually going to help us into making a more well informed choice while driving autonomous cars. Yeah.
So there's two approaches that you said. You wanted to use the cloud, like with a high 5G or something, where it's transmitting really fast and lots of data is being streamed up into the cloud and it's processing. What about the NVIDIA, where you have basically a supercomputer in the back of your car and it's doing all the processing hardware real time?
Yeah, I think there's always a trade-off between between these things, because let's say if I have everything on the cloud, but the problem in India is that probably you might not get internet connection, or maybe if you get internet connection, it might not be fast enough, right? So in these situations, it's better to have a supercomputer maybe somewhere in the back of the car, so that the predictions are done as quickly as possible, right? But the thing is that that is going to strain the car more, because you have to provide electricity to the computer. You need to have a cooling system, because these computers tend to get heated up a bit. So that actually comes with a trade-off. So but if you do everything on the cloud, things are bit cheaper. We have different cloud services which provides us a lot of flexibility in terms of pricing, as well as the compute power. So yeah, I think it depends on the use case, as well as the geographic region. Let's say in India, it's difficult for an autonomous car to work on the internet, because simply because there's not enough internet at every place. But let's say if you have good internet connection and you want something which is a bit cheaper, then you can go for having things on the cloud, and that in that way you can communicate easily to the cloud. Yeah.
Yeah, I think in the future, your mobile device will have enough computational power to do your driving, um,
Yeah.
because it'll have the machine learning chips in it. It'll have the deep AI chips. It'll have, have the multiple cameras, and you just put your mobile device into your car, and it'll do the computations for you. I suggest my first reaction with a lot of the researches you're doing is that I see lots of correlations, especially with your gesture technology, where you're starting to interpret uh, different signs and indications of what people want to do with their gestures. Um, and also that translating over into the self-driving cars, because the self-driving cars, there's a lot of signals, there's a lot of gestures that the other driver is doing that are indication, like when you come to an intersection, if another car starts inching forward, well, that your proximity detector will tell you that there was a change in the size of the box, indicating the difference between your distance to the car And so, is it if it sees a series of pulses where the size of the box changes, that could be an indication that that other car is going to proceed into intersection and you should yield. Whereas if there's a certain level of uncertainty, who's going to go in the intersection, maybe you accelerate through. So there's this work with gestures and communication, not only just algorithms for detecting where the road is going to be so important for autonomous cars.
Yeah, definitely. I think the point that you mentioned about having high compute, definitely, I that people are working on. I see a lot of research that is being going on, how to optimize these models, how to make sure that these models, very high level heavy models can learn on and work on uh, low resources. I think that's a very great point. TensorFlow has recently launched a TensorFlow Lite version, in which are used for mobile devices. I think that's the way forward, because uh, it is important to have a good model. It is important to have a very accurate model, but at the same time, you should work. You should make sure that your model uses as less resources as possible. So yeah, I think that's a very good point that you mentioned. And apart from that, I feel that I definitely the autonomous cars have come a long way from where they were, I think, a couple of years back. But with Tesla and Uber, they're trying to invest a lot of resources into this research. And I think maybe, let's say, 5 or 6 years down the line, we'll have a much more refined process of how to build a autonomous car. And yeah, and it's important to make sure that we have all the sensors which are up to the mark, which can take readings in real time, have all the proximity sensors and all the cameras up to date. But yeah, I think definitely, maybe 2 or 3 years down the line, these cars will be much more efficient and much more powerful in the coming years. Yeah.
Yeah, I think that the more universal you get, the wider your acceptance will be in autonomous cars, and where I've seen some cases where they've tried to do stereographic driving, where you set up two cameras, it creates kind of the two images, so now you can detect depth just from 2D imaging, and then you use CNN network or even a deep neural network with hidden features. And if you could, in the pipeline, uh, get the net so it could learn new objects while it's driving, then over time the car will actually get better at driving to the point that it can recognize lots of images, objects, and then transmit those objects up into the cloud, or receive from the cloud new training sets from other cars that are driving. So that I saw one case where it recognized a lady on a wheelchair. She's driving around in a circle in the middle of the road.
Yeah.
And it really did happen. Or where a bird flies across the road, it has to recognize those images and try to respond. What if a dog runs out in front of you? It has to detect, there's a dog that's running. It ran out in front of me. Do I hit it? Do I swerve over and hit another car? It's going to have to make some value judgments here. Do I hit the dog, or do I run into the other car, swerve and run into the other car? Um, can you speak to some of those decision making processes that the machine has to make?
Yeah, I think that is also very important, because let's say if something goes wrong, right? There are 10 different ways in a machine could react. But the machine has to do that in real time. It has to calculate that, if I take this decision, then ultimately it's going to affect these many people, or ultimately it's going to affect me, or ultimately I'm going to hit another car. So these decisions has to be taken in runtime. And this actually, I think, I watched the Tesla's, I mean, the yearly event that they have, and they were also referring to the same problem, that if there is a certain mishap on the road in front, then the machine has to make sure that it has calculated every possible aspects, and it is taking the least catastrophical decision of its all. So that will come probably with with more knowledge, with more subject matter expertise, and with more data. That you mentioned that, because these cars will ultimately get more data, it's going to train other cars as well. So let's say if the version 1 is maybe less successful, doesn't matter, the version 2 will have a lot of data, and it will also have the previous knowledge from the version 1 cars. So it's going to get better. But we probably should probably wait and find out exactly how these machines will work in some catastrophical situation, because that's when the machines will be tested to make sure that they make the right choice. So yeah.
So I would say that the machines over time will make better choices. That's been my thesis, is that the reason why you want to automate or continue to automate inside pipelines is that the machine will have more access to data, and so it'll make better decisions. But we will have to have some way of understanding why the machine made the decision so that we can evaluate whether or not it needs additional training, or if there's bad data that's been fed into the training that's causing it to make bad decisions.
Yeah, definitely. I think so. It's important to have a good data set, as it's more important to have a lot of data, but also it is important to have the data which is authentic, and so some sort of manual labor is still required to make sure that we inspect the images, we inspect the training data. We probably we maybe by hands or maybe by a script we can make sure that we are only training on the data which is relevant to us. So that is one thing. The other thing is that is the point that you mentioned, that uh, the network architecture has to has to be powerful enough, or has to be complex enough to keep on learning with these new images, right? So let's say if we use a traditional machine learning model, it does not mean that even if, let's say, you have a lot of data, the accuracy and the loss will not probably get better, because that's how the model architecture is. So it's important to have a good architecture. At the same time, it's important to have good training data. And once we have that, once we have an authentic training set, we have a good, well-defined network architecture. I think with time and with experience, with expertise, these models will eventually get better. These cars will eventually be the future. And I, I think companies like Tesla's and Uber are doing really good into investing in these technologies, which I think will be the future of mankind.
Yeah, right now the human being is the best driving machine, but in the future, there's with so many distractions, people texting while they driving, um, like lots of different. Um, when you go into a new area and you have to navigate the roads, there's lots of new data that you're actually exposed to, where a machine might actually do better because it has more access to data, and you're learning as you go, so it's a learning process while you're driving in new areas, where for the machine it's just another set of new parameters, and it's adjusting to those parameters, and maybe it's even has data models for that area, so it could navigate faster and better. So maybe in the future people will be moving around a lot quicker than they are today, because the machine is running autonomously, and it's making better decisions, and it can make decisions so much faster. I'm not saying that people should defer everything to the machine, but you can really see where automation is the preferred way to go. I was going to want you to talk just a brief moment. We're almost out of time, but I wanted you to talk about your research in cancer. What did you do in that field?
Yeah, so basically, so this was one of the first projects that I did. It was for breast cancer classification. So I think it's one of the when we are starting out, I'll recommend, if somebody who is listening to this podcast and is just starting out with machine learning, I'll recommend this data set, because this data set helps you solve a lot of problems. First of all, it helps you in a social cause, of course, but at the same time, I think it teaches you a lot. So let me just tell you briefly about the dataset. So the dataset contains date text data, column based data for around 600 patients, and out of these 600 patients, 50 patients had cancer, and the dataset included features like the area of the cell, which is in question, and this curvature of the cell, the radius of the cell, so things like that. So based on these values, the dimensions of the cells, we have to predict whether the cell is cancerous or benign. But the important thing to notice here is that we only had 50 patients who were diagnosed with cancer, and the rest 550 were not. I mean, they were clearly fine. So let's say if I did nothing, and if even if for every record that I got, even if I just say I do not do any processing, I could just say that the person does not have cancer, then also my accuracy will be high, because out of 600 times, 550 times I'll be correct, because the data set is like that. But the important point here to notice is we have to make sure that these 50 patients are identified correctly. So this actually comes as a sparse dataset problem. That is, there's a lot of sparsity in the dataset, and there are less number of negative examples in this. So in this case, we have to come up with a new metric. So accuracy is not our only metric, because as we have only already mentioned that even if we don't do any predictions, we can directly say that a person does not have cancer, we'll still have high accuracy. So we can come up with new metrics. So these new metrics are basically true positives, true negatives, false positives, and false negatives. Clearly, using these, we can come up with different metrics, which is the F1 score, or the precision recall. But let's just talk about these true positives and true negatives. So true positive states that the person has cancer, and you have identified it as correctly, which is a good thing. Then we have false negatives, that is, the person did not have cancer, and we have also predicted that the person did not have cancer, which is a good thing. Then comes true negative, that is, a person had cancer, but he said that that person did not have cancer. So this actually is the metric that we had to minimize. We wanted to make sure that we had enough data to make that prediction and say that the person, if he's suffering from cancer, we can say that you are suffering from cancer. And the fourth metrics states that if the person is not suffering from cancer, we can predict, or we say that the person is suffering from cancer, which is still bad, but it is okay, because at a later stage the person will come to realize that he does not have cancer. So it's a good thing. But we have to make sure to catch all the cancer patients so that the treatment can be done at an early stage. So this problem, this question helped me understand that accuracy is not the only metric. It's not just about the accuracy, it's about making sure that I have all the possible outcomes covered in the model, and that's how your model becomes very efficient.
Oh, that's pretty clever. Um, so what for the ones that that said that they had cancer, but they really didn't have cancer? How distressing would that be?
So yeah,
Do you mitigate that and say, well,
so
we're
basically
going to
for
alarm people?
each prediction, we come up with a confidence value. That is, we can say with this percentage of confidence that you don't have cancer, or we say that with this percent of confidence you have cancer. So of course, maybe let's say if we say a person has cancer but he did not have it, we can go ahead and ask him to undergo other tests, other medical tests, and maybe at a later stage, maybe like after the tests are done, he will be relieved that he did not have cancer. But at the same time, we wanted to catch all the patients.
So it's worth the alert.
Yeah.
Okay, well, Akshay, our time's up. Do you want to just share anything exciting? You just said you were working on gestures. Is there anything other things that are exciting that you're working on in the future?
So currently, my main area of focus is to minimize the resources that are being used for training a network, and I have done some sort of research on that, and I've come up with some best practices. which I will be open sourcing pretty soon, so that anybody who is working on networks, deep networks, or CNNs can look at that best practice document, and maybe have maybe try out a few things, and if that helps him, then that's good enough. And then apart from that, I'm working on the sign language project, which I think is very important to me, because I think in India it's very necessary to have people supporting each other, and people supporting children and kids with special abilities. But apart from that, I would encourage everybody to start, and maybe if they have interest, they should learn about AI and machine learning, because I think that's the way forward. And I would also like to thank you, David, for having me on the show, because this helps me reach out to a lot of people and also get a chance to talk to you. I think this has been very interesting for me, and I hope that we have a podcast soon, maybe a sequel to this podcast. Looking forward to it.
Oh, definitely. I will. I listen to the podcast multiple times. I think about it. I talk to other experts and stuff, and then there is. I think there's some things I want to return again with you on a podcast at a future time and talk on some other subjects that you've brought up. The one that's caught my attention is the your gestures, because the you mentioned about completing sentences and with the gestures, and I like that because um, if you're just getting one word, you can't really understand what they're saying. You have to take the word in context of a whole sentence. So I think that is an area I want to return back with you and
Definitely, yeah.
talk more about how you did that. Okay, well, thanks, and I'll talk to you later.
Yeah, thanks, David. All right, have a great day.
Bye bye.
Bye.